Patirana. No? Chaturanga. Nipun. Ne. Shivanta. Shivanta, hello. So can you hear me first?
Yes, madam.
Yes, madam.
How did me Shivanta ko? Shivanta නැද්ද?
Okay, madam.
මොකද ළමයින්ට වෙලා තියෙන්නේ? කතා කරන්නේ නැති මොකද? at least මේ ඉන්නම නම් yes කියන්න බැයි attendance වලට. නම් කියපු ඔක්කොගේම attendance නෑ අද. Right. So we'll go to this one. So how to find the bond order? So this is the equation. That is half number of bonding electrons subtract by the number of antibonding electrons. Okay. So to find the answer for this one, right? Dimatu, your answer is also incorrect. Answer is correct, but the number of bonding electrons and antibonding electrons are wrong. We'll see. So what is the first step? So first you have to draw the molecular orbital diagram, right? For this one. In the case of bonding order, right? Otherwise you cannot find the bonding electrons and antibonding electrons. Okay, right. We'll do. So this is the axis. Okay, what is this one? What is this axis? Energy, right? Okay, then you have to indicate the what? Element, name of the element, and then right, lithium. Lithium, how many electrons? Lithium? Huh? Three. Yes, 3. Right. Then what is the electron configuration? 1s2, 2s
1.
2s1. Yes, good. Then, so we are discussing about the s orbitals and what happens then when the s orbitals bonding. Okay, right. So considering oneness, so we have to consider oneness first. Oneness, okay. How many? So this is oneness, okay. Little bit difficult to write. Right, oneness. Okay, oneness. So we have to consider 2. Why these 2 oneness? So this is one atom and this is another one. Another lithium, okay? That's why we have to consider 2 lithium atoms because lithium 2 here, right? Oneness. So these are the electron. oneness වල තියෙනවා දෙකක්. එතකොට මේ අදාළ එක්කෙනාගෙත් දෙකක් තියෙනවා. මේ lithium atom ගෙත් දෙකක් තියෙනවා. හරි. Right? Clear? And then what happened when they bonding? So what is the energy considering the bonding energy? It's low. related to this one, right? And antibonding energies having higher energy, right? Like this. So this is sigma S, right? Sigma 1s, sigma 1s bonding molecular orbital, and this is sigma star, anti-bonding, right? Okay, we'll see. Then මෙතන කීයක් තියෙනවද? electron දෙකයි. So මෙතනින් එකක් මෙතෙන්ට එනවා, right? මෙතනින් එකක් මෙතෙන්ට එනවා. Sorry. Like this, okay? Okay. So now here we are having 4 electrons. We occupied 2 here and we are having 2 remaining. So we have to occupy them here. So this is antibonding, right? Okay. So the case of 1s is over. Then 2s we have to draw here or here. 2s orbital එක කොහොමද අඳින්නේ? මෙහෙද මෙතනද upper the bottom? Definitely upper because
Upper.
yes, higher energy, right? Here 2s, right? 2s A, 2s B, right? And similarly bonding and anti-bonding, right? So this distance should be equal, okay? Likewise, okay? So it's difficult to draw with using this mouse. Right. How many electrons? 1. Here 1. 1 is 1 electron. 1. 2 is 1. And here also, how many?
1.
1. Then this is sigma S2s, right? And here sigma star 2s, right? Then what happened when they are going closer and they are going to bond, right? Like this. Right? So here no electrons because we don't have any remaining electrons, right? Clear? Now using this molecular orbital diagram, you can find number of bonding electrons and number of antibonding. So it's going to be half, right? How many bonding electrons now? Bonding electrons. How many?
4.
Sorry? How many bonding electrons? How to calculate? 4, yes. So this is a bonding electron and we are having this one. Right? So 1, 2, 3, 4. 4 bonding electrons and how many antibonding? 2. Yes. 2. Then you can solve this one. The answer is 1. Right? Right? Bonding order is 1. This is the answer. Okay? Clear? So
Yes,
you
madam.
can write the electron configuration for molecular orbital using this diagram. We'll see how to write the electron configuration. So you know how to write the electron configuration for the atoms, right? We'll see about the molecules. So electron configuration equals, so this is equal sign, okay? Sigma 1 is how many electrons? 2. Okay. And then sigma star 1 is, right? Close the bracket. then 2 open bracket sigma 2 is here 2, right? Clear? Okay, right. Okay. Then, so now you know what happens to 1s and 2s. We'll see. Now we are going to look at what happens when bonding p orbitals, right? P orbitals. So p orbitals, you know, p orbitals are in dumbbell shape, right? Dumbbell shape. So there are two possible things can happen. Okay, that is, first one is overlap by end on end. First one end on end, and the other one is side to side. Overlap by end to end and side to side, right? So the two p orbitals can overlap either end on end or side to side. We'll see. Okay. The first case, we are going to look at end on end, right? So what are the possible things when we considering the waves? Two things can happen. That is, one, constructively and destructively, right? Two waves. Here also, they are waves. Okay. In the case of this one, end on end, right? This is the first case. And this is the second one we are going to look at, right? So in this one, so the waves can in phase, right? In phase. So the overlapping lobes, so you know these are the lobes, right? Lobes. And this is the node, right? Node, right? So these are lobes. So the first case, the overlapping lobes of the p orbitals are in phase, right? In phase. So they will form what? Bonding molecular orbital, right? In phase. Bonding molecular orbitals. Right? And here, so this it says the greater the amount of orbital overlap, the stronger bond. To form this stronger bond will form when the greater amount of orbital overlaps. So this leads to a directional character to the bond when other than s orbital. So because s orbitals are in shape of round, okay, that's the reason, right? Right. We are going to look at this example. Okay? Using this example, I will explain fluorine atoms. F. Okay. So this is the electron configuration, right? Okay. So 1 is to the p orbital. So we are considering this one. So the fluorine bond F2 bond results from the overlap of two singly occupied 2p orbitals, right? The 2p orbitals must point directly at each other for optimum overlap to occur, right? And the F bonds forms along the orbital axis. Along the orbital axis, we'll see. So the such bonds that result from head-on-head or the end-on-end orbital overlap are called sigma bond. Yes, sigma bonding molecular orbital, right? We'll go to the molecular orbital diagram. Right, this one. Right? So this is the p orbital diagram. P molecular orbital. 2p molecular orbital. Right? So here we are having one electron, and this one also another 2p atomic orbital from another fluorine atom. So it also have one electron, right? So this is sigma bonding molecular orbital. So end on end means what? Can you see? So this is green color and this is blue color lobe, and this is blue and this is green, right? So this is end of the lobe, and this one also end. So the overlapping occurs end by end, right? So what will happen? Electron density of the sigma bonding molecular orbitals is concentrated between the nucleus like this in here. Okay, electron density. So this is the place where the electrons located, or the you can see higher electron density in this region, right? So, and also the sigma bonding molecular orbital have two nodes, right? Like this, two nodes. So this is molecular orbital, bonding molecular orbitals and the shape, and you can see two nodes. Right? And then the here it says, so the bond form along the orbital axis, right? So this is the axis. So it's formed along the axis, right? So this is in phase, right? In phase overlapping. Okay. Then the other one, out of phase. If the overlapping lobes, so these lobes of p orbitals are out of phase, that means, so this is green and blue, and one is other way around, right? Then what will happen? We can have sigma star antibonding molecular orbital, right? Like previous case, like 1s and 2s case, sigma bonding and sigma star antibonding molecular orbital, right? So antibonding molecular orbital having how many nodes? How many nodes? Huh?
Two.
Two nodes.
2 or 3. Antibonding.
3.
3. Here.
3.
So this one here, here, and here. Right? 3 none. Right? Okay. So this is the molecular orbital diagram. Right? Right. The first case is over. That means end on end. And then we're going to look at what happens the second one. That means side to side overlap of two p atomic orbitals. So what will result? It form 5 bond. 5 bond. Basically, you know, when we discuss bond, right? They are, so you know, we are having different bonds. That means O2, H2, right? H2. H2 comma the single bond, right? What happened to O2? And what happened bond with CC, carbon, carbon. We are having here triple bond, right? Triple bond, right? Triple bond. And here we can have double bond, right? Right? So single bond means actually this is sigma, sigma bond. Sigma overlapping there, right? Double bond එක කියන්නේ මොකද්ද? මේ double bond එකෙන්
2 sigma.
No. So one always should be sigma and the other one should be 5. Right? Then triple bond එක කොහොමද එන්නේ? Triple bond. Yes. Always one sigma and the other two goes to 5 bond. Right? Clear? One sigma bond and others 2, 5. Right? Double bond එක sigma and 5. Right? Single bond එක කියන්නේ always sigma. Clear? Right. So this is the 5 bond case. 5 bond එකක් හැදෙන විදිය, right? So side to side overlap of p orbital, right? So again we can divide them into two cases, that is what? Considering in phase and out phase waves. Okay? So this is the first case, that is side to side overlap of two in phase p atomic orbitals. So you can see blue color, green color, green color. Okay. So this is in phase. What will result? 5 bonding molecular orbital. Here 5. Right? Not sigma. Here, this is 5 because side to side overlap. Okay. Side to side. So the how many nodal plane? Nodal plane. One nodal plane is there. Can you see? When in the case of side to side, right? And that nodal plane that pass through the both nuclei, right? It pass through both nuclei. Then the other one, if the p orbitals overlap, p orbitals are in out of phase, that means blue, green, here green, blue, like this. Okay, so it will form 5 star antibonding molecular orbital. Right? How many nodal planes? We can have 2 nodal planes. right? Like this. Okay. So only this phi and sigma is going to be changed and in the previous one, right? Clear?
Madam,
Yes.
excuse. Madam, why the previous one has nodes and this one has nodal planes?
No, no, similar one. So here you can see node. Can you see this is a little bit huge and combined. It's like a plane, right? Plane means actually we are considering crystal planes, so several things. Okay. So the simple idea is what? That means there are no electron density or no electrons locate in that region. That is the simple thing, right? So you need to know what happens. Basic things, right? That means what happens, the two cases. That means end and what happened overlapping end and side, right? And how to draw this diagram. Okay. So this hybridization is a huge section, right? So I'm simply explaining the basic things because that much details you don't want, right? Only you have to know how to form sigma and phi bonds. So this is the basic principle, right? Clear? Other than that, we can go for the hybridization. So this is a little complicated, right? Okay. So you said that the one formed by end overlap of p orbital is stronger than the bond formed by side. Because you know the always sigma bond is stronger than the phi bond, right? Most stronger means most stable, right? It means the sigma bond molecular orbital is more stable than phi bonding molecular orbitals, right? Further, you can describe using the energy, okay? So the sigma and phi bonds. So considering the p orbitals, here it's described considering p orbitals. So hybridized orbital overlap, end to end, right? These type of bonds are known as sigma bond. And then the phi bond. So the phi bonds form when the multiple bonds are involved, such as in double and triple bond, right? So usually formed by unhybridized p orbitals. So don't worry about this word, right? hybridized and unhybridized. Just you have to know what are the type of bonds in single, double, and triple bonds, right? And what happens in the case of 1s orbit and 1s atomic orbitals, okay, and p orbitals. Yeah, only I have mentioned 2p having electrons in only like this, okay? So we can discuss what happens 2px overlapping with the 2px, 2py likewise, okay? So, but in your case, I'm not going to, in your level or for this course, you don't want to go in that much detail, right? Right. So do you have any other questions? Yes. Do you have any other questions? So is this clear to you? Can you hear me?
Yes, madam.
Right? Clear? Okay. So I will, so that part is over, right?
Excuse me, madam.
Yes.
Madam, when we write in the molecular orbitals for fluorine, do we have to write the whole electronic configuration, and after that we have to draw the whole molecular orbital diagrams? That means 1s2,
Fluorine.
2s2.
Fluorine,
Yes.
yes. So you are asking you have to draw this one as well. 1s2.
Yes, madam. All the
No,
electronic
no.
configurations.
That means here.
That means, madam, fluorine has the electronic configuration is from starting from 1s2, 2s2.
Yes,
Likewise,
yeah. So you are asking about you have to draw this one as well.
from the
That means
yes, from the beginning.
From the beginning. That means like this. 1s.
Yes, madam. Yes.
No, no.
Then
Then
from the
only
last.
yes, only considering. So that is depend
Yeah.
on the question, right? So in your case, I'm not going to ask to draw all the things. So that is unfair, okay? So this is not the degree of the chemistry neither. So I only, if I ask a question from this section, I am only refer to the this slide. That means if I ask you to illustrate the molecular orbitals overlapping in p orbitals, right? තේරුණාද? p orbital වල molecular orbitals overlap වෙන එක describe කරන්න කිව්වොත් you have to only you can use this example, that means fluorine, and only you can refer this one. That means one is only this one.
Okay, madam.
Singly occupied orbital, right? Then, but you have to have knowledge regarding the possibilities. That means end to end overlapping and side to side. What happens end end? That means like this. Only these things, right?
Okay, madam.
Right.
Thank you.
Yes. When I was noticed in the mid exam, some students cannot remember the periodic table, right? But I already gave the number of electrons in that question. I think first one for phosphorus and sulfur. Can you remember? So I noticed some of you cannot write the electron configuration, the basic things. Okay. So in this course, you have to know the elements in the periodic table starting from 1 to 30. Right? ඒක දැනගෙන ඉන්න ඕන. Right? 1 to 20 ඔයාලා ඉස්කෝලේ ඉගෙන ගන්නවනේ. Right? හයිඩ්‍රජන්, හීලියම්, ලිතියම් ඔය වගේ. එතකොට එතන ඉඳන් මේ d orbital වල මුල 10 දැනගෙන ඉන්න ඕන. Right? 21 22 ඉඳන්. Starting from the scandium. Right? ඒ ටික දැනගෙන ඉන්න ඕන. Right? ඊට එහයින් මං අහන්නේ නැහැ. So that is unfair. Right? And then how to identify the things in the periodic table. Mass number එක මේ atomic number එක ඒවා මම කියලා දුන්නා. ඒවා identify කරන හැටි දැනගෙන ඉන්න ඕන periodic table එක දුන්නාම. Right? අහපු නැති කියපු නැති දේවල් අහන්නේ නැහැ. Right? සහ deep chemistry expect කරන්නේ නැහැ ඔයාලගේ course එකෙන්. එහෙම evaluate කරන්නේ නැහැ. Okay? Right. So with that, I'm going to stop this session. That means this part. Okay. So for your quiz 2, quiz 2 ekai 3 ekai most probably we will have on in a one day. එකම දවසේ තියෙයි සමහර වෙලාවට, right? Right. We are going to look at another part, another session. I'm going to start the chemical calculation. Right? Right. Chemical calculation. Can you see the screen? Yes or no?
Recording
Yes.
in progress.
Yes. Quiz 3 basically related to this one, okay? Quiz 3. Right. So these are the learning outcomes, right? At the end of this lecture, you should be able to understand units and conversion of units, apply chemical formulae, and identify chemical equation, and you are going to study how to write the chemical equation, and differentiate the relative atomic mass and molecular mass, define mole and molar mass. You already know, I think, molar and molar mass, right? Okay. So a little bit interesting section, okay? So because you are having the things to do without listen to me, right? Okay. So unit. First one, chemical calculation, right? Chemical calculation. So read this one. Having the fundamental knowledge on chemical calculation is essential to understand the chemical processes, right? Chemical processes involved in industries as well as in technology, right? So definitely, chemical calculation. If you are going to work at a industry or sometimes you have to work in a laboratory as a technologist, they are actually, you have to engage with chemical calculations, right? Different chemical calculations, sometimes titrations, synthesis part, right? Right, likewise. Okay, so it's necessary to having a fundamental knowledge regarding the chemical calculation. Right? So these are the things that we are going to cover under this topic. Okay? Right. The first one, units. Why we need unit? Why we need units?
For machine.
For
Machine.
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 For meshing or measurement?
Measurement.
Measurements, yes. What about the others? Do we need units or another?
Yes, ma'am.
Yes, definitely we need. Why? So you know every field of science. Yes?
For quantitative comparison.
Yes. So every field of science, so we are taking measurements, right? In our day-to-day life or in our professional lives or in your life, that means when you are in a workshop or in a laboratory, right? So we are taking measurements, right? So that is necessary if you are a chemist or if you are a physicist, if you are an engineer or if you are a technologist. So all of us taking measurements, right? So taking measurements. So we need to understand that measurements, right? Am I right? Am I correct? We need to understand, right? That means I'm taking measurement in my own way, right? So you guys going to take your measurements in your own. That means you are using your own unit, right? So I'm talking about, I'm using another one, okay? Can we have a common argument or common understanding about the things, about that measured things? If we use different units or different language for the measurement, can we come to one table and can we discuss the things or the observations? Huh?
No, we can't.
No, definitely we cannot, right? So likewise, so we have to have a basic same language for the measurements as well, right? Then only the things we measured or the things we doing in a laboratory scales or the production scales, we can discuss and get value for them. Otherwise, others cannot understand, right? So the units of the measurements is a definite magnitude of a quantity, right? So the measurement is a process of determining how large or how small a physical quantity. So when we compare to the basic reference quantity, right? So the measurement is a process to determine how long and how small a physical quantity when we compare to the basic reference quantity, right? So here it says the world now use the international system of units for measurement. So this is the abbreviation SI, right? So these are the common units we use to measure the physical quantity of these kind of a things. That means first one, mass. The unit is kilogram. So this is the abbreviation, right? So here, can you see there is no any space between K and G. Here the simple and simple letters. What about the length? Meter. Temperature, Kelvin, not Celsius, right? SI is, unit is Kelvin. Okay. The amount of substance, molar. Mole. Abbreviation is mole. Time, second. Electric current, ampere. Luminance intensity, candela, right? So these are the basic units. Okay, right. And then conversion of units. Conversion of units. So the many scientist activities actually involve numerical calculation, right? That is measuring, weighing, preparing solutions likewise. So it's often we need to convert quantity from one unit to another, right? So I think this is not very difficult task for you, right? So sometimes we need to change the one unit to another one, right? So that is we call conversion of unit. So is it necessary? Here there is a question. Is it necessary to convert convert quantity from one unit to another? Yes, definitely. So sometimes we are having time in seconds. So we have to convert them into hours. Okay. Or sometimes we are measuring distance from kilometers, right? Then we have to convert them into a meter, right? Likewise. And sometimes we are measuring mass using grams. So you might ask to convert them into milligrams, likewise, right? Okay. So how we are going to convert? So conversion of units. So this is the way we are convert units into one unit to another one. Okay. So first you have to find the relation between units, right? What is the relationship? That means millimeter, centimeter, meter, and kilometer. The relationship between these one. Okay. First you have to find that one. Okay. Here 1 liter equals to 100 milliliters. Okay. So the conversion factor, then original quantity into the conversion factor equals to equivalent quantity. Right, this is the way. So here it is, they use the conversion factor like a fraction where the unit you want is on the top, that means numerator, and the unit given in the problem is on the bottom, that is denominator, right? So we'll do one thing, one question. So this is the example. Okay. So you ask you to convert this milliliter, amount of this one, milliliter into liter. So this is the conversion factor. Can you see? So this is the given quantity. So the relationship is this one. 1 liter equals to 1000 milliliters. Okay. Then, so this is 1 liter. So the unit you want is the top, on the top. That means numerator. 1 liter divided by 1000 milliliter. So this is the equivalent quantity. Clear? So these are the very basic things. You know these things, right? Okay. We'll move. Oh, all right. So do this on speed of a car. So you ask you to convert into a kilometer per hour. Right. Quickly do this one. What is the answer?
Five 5.55 kilometers per
Huh? What is your answer? 5 point? Yes.
five 5.55.
No. What's your name? Yes. What's your name, Puta?
Hasin.
No, Hasini, that is not correct. Check. Check your answer. The others, yes, most of your answers are correct. Yes. So how to convert this one? First, you have to know the relationship between the meter and what? Kilometer. And then you have to convert second into hours. Okay. So 1 kilometer equals to 1000 meter. And what about the 1 second? 1 second in means how many? Sorry, 1 hour means how many seconds? 360, right? This is 1000. Okay. So you have to ask to convert this one. This is the original quantity. And this one. 1000 into this one, right? So what is the answer? Simply this is
72.2.
72. The hard thing for hard. So simply 72 kilometers per hour. Okay, right. Right. Then prefix. So sometimes we are having problem when we use SI unit. That means the further one problem is with any system of the measurement is that the size of the units sometimes turn out to be inconveniently large or small, right? So for an example, in the chemistry, we can describe the diameter of the sodium atom using unit of meter, right? If we are going to use the SI unit, sometimes we may face some inconvenience because that measurement sometimes that measurement can be inconveniently large or small. For an example, when we discuss the diameter of the sodium atom in meter, right? In meter, you can write 0.0000000372, like, right? So it's very inconvenient to use that kind of a value like this, okay? 0.000000 likewise, okay? The value is in here, right? When we consider meter, and if we use the unit meter, right? So at that time, right, for this reason, actually, SI units are modified through the use of this kind of a prefix, right? So we can use prefix to refer either smaller or larger quantities. For an example like this. So these are the prefix. Okay. So here starting like this, 10, right? So we are using 10 to the power, right? 10 to the power 1, 2, 3, 6, 9. Okay. And the smaller quantities you can describe using minus 1, 2, 10 to the power minus 3, minus 6, minus 9, minus 12, likewise. Okay. So these are the name. Okay. So we are using kilo. Meter, kilometer means kilo means 10 to the power minus, sorry, minus, not minus, 10 to the power 3, right? 10 to the power minus 3 means milli. Minus 6 means pico. This is the symbol, mu m. Okay. And minus 9 means nano and pico. Mega means 10 to the power 6, likewise. So these are the prefix we always using in our day-to-day life, right? Okay. Right. So those are the basic things, and okay. Then the molecules. You know, because we already used this term. Molecules. What are molecules? It says is the aggregate of at least 2 atoms in a definite arrangement held together by chemical forces. So it's actually aggregate. We call this as an aggregate at least 2 atoms in a definite arrangement held together by chemical forces or chemical bonding, right? So water is a pure element, but it consists of molecules made up of 2 hydrogen atoms each, right? So these molecules are joined in a fixed ratio, right? For example, hydrogen gas. Okay, that is 2 hydrogen atoms. But what about the water? It's hydrogen and oxygen. 2 hydrogen atoms and 1 oxygen. So there is a ratio, right? So the molecules are also electrically neutral, like the atoms, right? Then the molecules actually we can divide into 2 groups, that is diatomic molecules and polyatomic molecules. So when you heard this word, that means diatomic, definitely you can identify there is a 2 atoms. Okay, diatomic means it contains only 2 atoms. Okay, so what are the diatomic molecule? Example, first one hydrogen, yes, definitely H2, H2, yes. What else? Diatomic molecules, 2
O2.
water, no.
O2. Oxygen.
O2, yes, O2, yes, O2, N2, F2, fluorine, Cl2, right? N2, nitrogen, likewise. These are the diatomic molecules. What about the polyatomic? And also diatomic molecules can be different elements, 2 different elements, atoms of 2 different elements. So you can have, yes, 2 atoms, that means similar 2 atoms or 2 different atoms, 2 elements, that means HCl. Okay, this is also diatomic. HCl, 2 elements, but right, and carbon monoxide. Okay, KBr. Likewise, they are diatomic. Contains only 2 atoms. Okay. What about the polyatomics? Molecular containing more than 2 atoms. Polyatomics means molecular containing more than 2 atoms. So you know, vast majority of molecules contains more than 2 atoms, right? Most of the molecules are polyatomic molecules. For an example, ozone, O3, water, H2O, ammonia, NH3, okay? Likewise, polyatomic and diatomic molecules. Okay. Then iron. Ions. Iron is an atom or group of atoms that has net positive or negative charge. Atom or group of atom that has net positive or negative charge. The number of positively charged proton in the nucleus of the atom remaining in the same during the ordinary chemical changes. We know that one. But what happens then? How these atoms obtain this positive and negative charge? Because these negatively charged electrons may lost or gain. Okay? So the electrons are the mainly participate for this process. That means to gain plus and negative charge for the atoms or group of atoms. Okay, so the loss of one electron or more electron from a neutral atom result in a what? Loss of electrons, cation, right? Electron yang kain වෙනවා කියන්නේ, so we can have cation. So an ion with the positive charge. Okay, so the anion is an ion. So those are having net charge in negative. So because due to an increase in the number of electron, right? Okay. For an example, cation sodium. First group element, first sodium. Sodium, 11 electrons. So sodium wants to remove that one, that electron. So sodium plus, okay, and chlorine, halogen group. Right. So these are the common cation and anion you can find in the periodic table. So you know an atom can lose or gain more than one electron. For an example like this. So magnesium here lose two electrons, calcium, and here gain two electrons. So aluminium, 3 plus, right? So these are the main cation and anion. Okay. So this is the periodic table, right? So sometimes you can see, so these are possibility. Fe2 plus, Fe3 plus, like that. Okay. So again, iron also we can divide into monoatomic ion and polyatomic ions, right? So monoatomic means only monoatomic ion we can divide into two groups, that is mono previously we had a diatomic, this is monoatomic and polyatomic. So but the monoatomic means only one atom. Likewise, so these are having only one element, okay, right? Sodium plus, these are monoatomic. The polyatomic means the two or more atoms can combine to form an anion, right? That has plus or negative charge. Here, two or more atoms can be combined to form net positive and net negative charge. For an example, this is hydroxide ion, right? This one, like this, OH minus, right? So this is negative, right? OH minus. Cyanide, CN minus, and ammonium ion, NH4 plus or minus here, plus. right? So these are polyatomic ions, right? Because two or more atoms from different element, right? So monoatomic ion, right? Monoatomic ions means you can have both plus and minus, right? But only one atom. I only gave the example only this, ne? Okay. So these kind of things. So all these are monoatomic. Not these things, sorry, yeah. You can consider all these things because no any combine, no any combination. So all these are monoatomic, right? Monoatomic ion. We'll see polyatomics. Here. So these are polyatomic ions, right? Right, we'll see. Okay. Then formula, chemical formula, right? So you know now what are the atoms, elements, and molecules, ions, right? Then we are going to write formula. Okay. So we use to chemical formula actually we use to express the composition of molecules and ionic compound in a term of chemical symbols, right? Don't worry about these definitions. I'm not going to ask the definitions in this part, right? Only we want to know how to write the chemical formula, how to write the reaction, likewise, okay? The composition means actually the elements present, right? Elements present and the ratio in which the atoms are combined, right? So you know already how to write the chemical formula. We'll see. For an example, sodium chloride. Sodium chloride. So this is the chemical formula. So in here, looking at this chemical formula, we can identify the ratio. That means the composition, element present, and the ratio which the atoms are combined. What is the ratio? 1 to 1, right? 1 to 1. That means if there is one sodium atom, definitely there should be a chlorine atom, 1 to 1 ratio, right? And this one, second one, sulfur dioxide, SO2. How many sulfur atoms are there? 1. How many oxygens? 2. That means ratio 1 to 2, right? To form a sulfur dioxide, SO2, definitely we have to have 1 sulfur atom and 2 oxygen. That is the simple thing. The carbon dioxide, similar to the previous one, carbon and oxygen. මොකද මේකේ තියෙන elements දෙක carbon and oxygen. Carbon, how many carbon atom? 1. The ratio is 1 to 2. 1 carbon and 2 oxygen. Can you remember? We draw the structure. This is a linear molecule having what? Double bond. So I ask you to draw the electron dot structure. Can you remember? Carbon dioxide. Okay. Then sulfuric, H2SO4. How many hydrogen atoms there?
2,
2. Sulfur,
4,
sulfur,
1,
1,
1. Oxygen,
4,
4. Good. Then aluminium hydroxide. So this is the ratio is here. The ratio is 2, 1, 4. Right? 2, 1, 4. Aluminium hydroxide. Write the number of aluminium, oxygen, and hydrogen. 3 elements are there. How many aluminium atoms here?
2,
2. Oxygen,
3.
Three.
Sorry, 6.
3,
3. 6. What else? What about the others? Hydrogen,
6.
6. 6. Yes. We'll see. So let me explain. Yes. So what about the aluminium? Definitely 2 aluminium, right? 2. So this coefficient belongs to all three elements. That means there are then 2 aluminium, right? What about the oxygen? Here, you can see the brackets. That means you have to multiple by this one. Definitely 3 oxygen there, and these 2 also coefficient of this oxygen, right? Then 2 into 6, 2 into 3 means 6, right? Likewise, hydrogen, 3, and you have to multiply by these 2, then 6, okay? Number of atoms. So looking at the formula, we can identify the ratio, okay? Right. So this is an ionic compound. Ionic compound. Sodium, if for an example, sodium chloride, you know that one. So the ionic compound to be electrically neutral. Ionic compound to be electrically neutral. That means the sum of the charges on the cation and anion in a formula unit must be 0, right? Then if the charges on the cation or the charges on the cation or the anion are numerically different, we have to use this one. That means we are looking at how to write this formula, right? For an example, consider this one, KBr, reaction between potassium and bromide. So So what is the formula? Chemical ionic compound. You know this one is plus and this one is minus. Okay. Bromine. Then we'll see the plus one positive charge. Positive charge plus. Then what is the answer? 0. That means no any charge. That means we can write the chemical formula. This is the KBr, no any charge. Okay. Right. Then think 2. Think 2 plus think 2 plus and iodine. මොකද්ද equation මේ iodine minus 1. Oh my, we don't usually indicate the 1 minus, right? What is the net charge? කොහොමද මේක හදන්නේ දැන්?
+1.
Plus 1 means we have to add what? 2 plus 2 plus minus 1 means net charge එක. What is net charge? Plus 1. Plus 1 means we have to add another minus charge to make this plus neutral. Right? මේ plus එක නැති කරන්න අපි තව minus එකක් දාන්න ඕනේ. එතකොට කොහොමද වෙන්නේ? think formula එක කොහොමද? How many?
I2.
මෙහෙම තිබ්බොත් chemically neutral? Then no. Here
I2.
Yes, we have to add another minus 1 means I2, right? So this is the correct formula, right? Right. Write the L3 plus O2 minus. Aluminium oxide. How to write?
Al3 or Al4.
Al and oxygen. Aluminium oxide. So what is the charge? Al3 O2.
Oh my.
So what is the ratio? ALO.
Al2 or 3.
Yes. Al2O3. Look at this one. Al2 into 3 means 6 plus. How many minus? Here, minus 2 into 3, 6 minus, then this can be, we can cancel out. The new compound is electrically neutral, right? Clear? Okay. So these are some examples, okay? Cation and anion. Cation and anion. Right. Write the chemical formula for this one. H plus carbonic, to form the carbonic acid. C2O Uh, three, 2 minus. Can you write? Two minus, okay? It's difficult to write actually. This one and this one. And iron is this one. H, how much? What is the formula?
H2CO3.
H2CO3. Yes, correct. That is carbonic acid. Okay. Nitric, HNO3. And then ammonia, sulfur dioxide, carbon dioxide, silicon carbide, SiC, silicon carbide, sulfuric H2SO4, right? Right. So these are the practice questions. So you can do this one, right? You can practice. This one, right? Okay, right. Okay, then we are going to write the chemical equations. Chemical equations. The chemical reaction is represented by an equation. Okay, chemical reaction. So there are several chemical reactions. So each and every process we are having chemical reaction, right? For an example, you have experience in titration. So there is a reaction, okay? And corrosion of metals, that is also due to a reaction, okay? So we can represent the chemical reaction by equation, okay? So the chemical reaction can be transformation of compound to one or more compounds. Yes, it's a transformation of compound to one or more compounds. And also, or it can be reaction between two or more compounds, right? Two or more compounds to form one or more compounds. Or the reaction between elements, or element, and we can have a compound to form a one or more compounds. Elements are. For an example, what? Elements, aluminium and oxygen, likewise. Okay. The important thing is, like here, atoms are neither created nor destroyed during any chemical reaction, like energy. Okay. අපේ atoms create කරන්නවත් destroy කරන්නවත් බෑ chemical reaction එකක. That is the very important rule, and it's a norm actually you have to keep in mind. Right. So we are going to write the chemical equation. Right. chemical equation. So this is for an example, this is an equation. For an example, hydrogen gas, H2, can react. We are going to burn with the oxygen, O2, to form what? Oxygen or water, H2O, right? So this is chemical reaction, right? Here, so we are having in a chemical reaction, we are having reactants and products, right? Reactants and products. So basically hydrogen react with O2 to produce water. Sometimes the question will be like this, hydrogen gas. You have to know what is hydrogen gas, H2, oxygen, O2, and formed water, H2O, likewise, okay? In a chemical formula on the left side, represent the starting substance. So these are the starting substance, right? Left side. So we call it as a reactant. And the other side, right side, it indicates the products. In this example, it's a water, H2O, right? And these numbers in front of the formula, we call it as a coefficient. These are the coefficient. Number in front of the chemical formula. So these are the coefficient, right? So as I told you, in a chemical reaction, atoms are neither destroyed or created. Yes, atoms are neither created nor destroyed in a reaction. So the chemical reaction must have an equal number of atoms of each element on each side of the arrow. That means this arrow. So we have to calculate, we have to count the number of atoms each side, this side and this side. Okay, so the number of atoms should be equal because we cannot neither create nor destroy. Okay, and finally you have to indicate the state. That means gas, liquid, solid, or aqueous, AQ. Okay, right. And so we are going to look, we are considering this example again. H. So the question asked me about reaction. So this is plus reaction, okay? O2. Then we know only about H2. These are the products, okay? So we have to balance the equation. Simply, you have to balance the equation. First you have to write. To count the atoms, hydrogen atoms, how many hydrogen atoms here? 2, right? 2. Hydrogen atom 2. So left side 2. What about the right side? That is 2. Right. Then that is okay. Then what about the oxygen? Here, how many? 2. Right? What about the right side? How many oxygen? 1. Then what will happen? 1. So this equation is not balanced. So this is unbalanced. So we have to balance the equation, right? Because neither we cannot create neither create nor destroy the atoms. So here we are having 2 oxygen. So definitely right side also we have to have a 2 oxygen. 2 oxygen කරන්න කොහොමද? Simply you can write මෙතන 2. Harijan?
No.
No, definitely. So H2O2 means what? Hydrogen peroxide. Okay? No, this is wrong. Then what shall we do? Then to have the two oxygen, you can write 2 here, right? Then now oxygen is balanced, right? 2 oxygen, right? When, so we wrote the coefficient here, right? So what happens to the now hydrogen? Here, 4 hydrogen, right? Right side, 4 hydrogens, here only 2 hydrogen. So again, we have to balance the equation. Simply you can write 2 here, right? Now we are having 4 hydrogen here, 4 hydrogen here. Then you have to write the what? State of the compound, okay? So this is liquid. Clear? So this equation is balanced, clear. The total mass of the reactants LHS equals to the total mass of the products, right? Products and reaction. So the mass balancing, right? Clear? Okay. So another equation. So this reaction of burning gas methane in air. Air means oxygen. Okay. So what are the products? Carbon dioxide, then what? Water, right? So this is the way. Methane plus O2, carbon dioxide, water. How many carbon? One carbon here. Hydrogen 4 atoms, oxygen 2. Let's consider the products. Carbon 1, oxygen 1, 2, 3. 3 oxygen. Hydrogen 2 hydrogen. So look at this one. So the atoms are not equal. So this is not a balanced equation. So we have to balance the equation. So how we are going to balance the equation? So here 2 and 3. Okay. So hydrogen. Here 4 hydrogen. Here 2 hydrogen. Then starting from the hydrogen. To balance the hydrogen, you have to insert 2 here. Right. Then the hydrogen balance. 4 hydrogen, 4 hydrogen. Right. Okay. Then again consider what happens to the oxygen. Now hydrogen balance. Okay. Hydrogen balance. Okay. Now it's okay. No need to consider the carbon. Okay. So what happens now? Oxygen here, oxygen. Here, how many oxygen? 1, 2, 3, 4. Now we are having 4 oxygen here. So simply you can insert 2 here to get the 4. Right? Now this is the balance equation. Okay? Right. Right. So you can do this one as a homework. Oh no, there is no any things to done. Right. Take this one, do this as a homework, right? Okay. There is a question, H2O to 1094. If you can ask the question, it's better. If you have any unclear point, please ask, but I cannot. So this, your question is not clear actually. It's not clear to me. Right, you can do this one. Okay. Right. Okay. So with that, I'm going to wind up the session. Do you have any question? Do you have any question? No. Good. Right. Right. Okay. Right. So with that, I'm going to wind up the session. So you don't have any questions. Okay. Right. Thank you very much. Have a nice day.
Thank you, madam.